Hi, welcome to the video solution for Edexcel Physics. This is IAL Physics Unit 6, June 2018. So let's start. Question number 1. A student has a sample of wire made of an unknown metal. In order to identify the metal, she determines its resistivity. The student estimates that the diameter of the wire is approximately 0.5 millimeter. She measures the diameter of the wire using micrometer screw gauge. Explain why the micrometer screw gauge is an appropriate instrument for this measurement. A typical question of asking reason why we are using some given um, instrument. So generally we talk about precision, or least count or resolution, and then we talk about the percentage uncertainty. And then we say that because the percentage uncertainty we can determine from this value, so you can say that the resolution of micrometer screw gauge is 0.01 millimeter. That gives us a percentage uncertainty 0.01 divided by 0.5 multiplied by 100. Then it will give you the value around 2%, and this 2% is a percentage uncertainty which is very small. That's why we use this particular device to measure such types of measurement like diameter. So we talk about resolution and the percentage uncertainty. In place of precision, you can write resolution, because in new specification they have replaced the word precision with the resolution. So for new specification we don't use precision, we use resolution, the smallest measurement. Question number 2 or part 2. Describe 2 techniques she should use to make this measurement as accurate as possible. Again, a typical question, how to improve the reading or how to get more accurate reading. We talk about checking the zero error and then repeated reading, so that we can use mean value to reduce random error or to remove any anomalous result or to get more accurate reading. Part 3. She measures the diameter as 0.275 millimeter plus minus 0.003 millimeter. Calculate the percentage uncertainty in the measurement of the diameter. So if you calculate the percentage uncertainty, so percentage uncertainty is uncertainty delta D divided by measured value D multiplied by 100. That's how you find the percentage uncertainty. So you can calculate like 0.003 divided by 0.275 multiplied by 100. It gives you 1.1%. This is percentage uncertainty in the diameter. B. The student measures the length and resistance of the wire and obtains the following results. Length is this and resistance is this. Calculate the resistivity of the metal. So you must understand the resistivity formula. So the resistivity rho is equal to RA by L. Or you can say that RA is the area, and area is pi r square or pi d by 2 whole square upon length. So you have diameter, you have length and the resistance, and you can find the resistivity. So you can just substitute the value. You can do rho is equal to R. R is the resistance, 6.48 times pi 3.14 times d by 2, and d is 0.275, and remember this was in millimeter, so you need to do 10 to the power minus 3 in meter divided by 2 whole squared and divided by length, and length is 0.8. So once you solve this, so resistivity would be equal to 4.81 into 10 to the power minus 7 ohm meter. Calculate the percentage uncertainty in your value of resistivity. So we need to find the percentage uncertainty in the resistivity, and if you see the formula for resistivity, the formula for resistivity involves resistance, area, and the length, and all the three quantity have its own uncertainty in their measurement. So you need to find a percentage uncertainty of every quantity involved in the formula, like percentage uncertainty in the resistance, percentage uncertainty in the area, percentage uncertainty in the length, and then you add all these percentage uncertainty to get this percentage uncertainty of the resistivity. So how do we do that? First of all, you need to find delta R by R, multiply by 100. If you do that, delta R is 0.03 divided by 6.48, and it will give you 4.6 into 10 to the power minus 3, or you can say that this is 0.46% when you multiply by 100. And then you find the percentage uncertainty in the length, so you delta L divided by L multiply by 100. If you do that, 0.001 divided by 0.8, so it will give you 0.125 or 0.13%. And only left quantity is the area, so percentage uncertainty in the area is twice the percentage uncertainty in the diameter, because area is pi d square. Due to this square, because we have percentage uncertainty in the diameter, so the percentage uncertainty in the diameter, delta d by d, okay, it is twice of 1.1, and then you add all these three, so you can get delta rho, percentage uncertainty in the delta rho would be equal to 2.8%. You need to add all these to get the percentage uncertainty. That's your answer. The table lists the resistivity of some metal used in resistance wires. Okay, so this is the list of some metal with the resistivity given. Explain which metal wire is most likely to be made from. So there are two techniques to figure out which material we are dealing with if some values are given. One technique, which is quite long, is you calculate the percentage difference and the percentage uncertainty that we already have, and we compare the percentage difference of every metal with the percentage uncertainty to figure out which one percentage difference is less than the percentage uncertainty. And the second method is you calculate the upper limit or lower limit, upper bound or lower bound, so upper limit or maybe lower limit of your resistivity value, and then you compare the upper limit value or resistivity value with any one of the given and see which one falls within the calculated value. And how do we find the upper limit and the lower limit? So the idea of finding upper limit of resistivity, I'm writing in short, upper limit of resistivity is you multiply your calculated resistivity by 1 plus the percentage uncertainty in the resistivity. So if you do that, rho times 1 plus percentage uncertainty that we find is 2.8% in a previous calculation. So 2.8% is 0.028. So now you have your resistivity. Your resistivity is 4.81 times 10 to the power minus 7. This is your resistivity times 1 plus 0.8. That means 1.028. Once you multiply this, so your upper limit of resistivity will be 4.67 times 4.94. Just let me check once again. Yes, indeed, it is 4.94 10 to the power minus 7 ohm meter. Clearly, the resistivity of constant wire 4.9 10 to the power minus 7 falls within the limit, within the upper limit of your calculated value. That means your wire is constant wire. There is additional step. If you wish, you can check the lower limit as well. So for lower limit, I'm doing here. So for lower limit, if you wish, you can do rho times of 1 minus percentage uncertainty. If you do 1 minus, then you have a lower value, and you will find that, just for your understanding, I'm giving you idea. If you find the lower limit, then you find that the value of constant wire within the lower and the upper limit. That's why your wire is constant wire. But you don't need to check the lower. You can check either of the two, either upper limit or the lower limit. Most of the time we check upper limit and we say that whether it is fall within the limit or not. So that's how we can figure out the material from which the wire is made of. Question number 2. A student connects a variable frequency signal generator to an oscilloscope. The oscilloscope displays how the output from the signal generator varies with the time as shown. One on the horizontal scale of the oscilloscope screen, one division represents 50 millisecond. Remember, it is not meter, it is millisecond. It's a time axis. On oscilloscope, the horizontal line is always time axis, so it is 50 millisecond. Show that the frequency of signal is about 6.7 hertz. So this is the oscilloscope. So you can see that from this point till this point. That's what I generally do. I just take only one wave, and that means if you measure this distance, this distance, this is the total time for one wave, which is the time period. And you see that there are three divisions there, and one division is 50. So this total distance is 150 milliseconds. So the total time for one wave is 150 millisecond, which is the time period. So frequency is 1 divided by 150. Don't forget to write milli. Most common mistake generally students do. And once you solve this, your answer will be 6.66 hertz, which can be rounded off as 6.7 hertz. Part B, the student uses the variable frequency signal generator as a variable alternating current power supply and connects it to a coil of wire. A coil of wire has a property known as impedance Z, which is given by Z is equal to V upon I. So we can find impedance, voltage divided by the current, where V is the potential difference across the coil and I is the alternating current through the coil. Z is thought to vary with the frequency f of the alternating current, as Z square is equal to 4 pi square L square F square plus K square, where L and K are constant. Okay, so Z is equal to V by I. Write a plan for an investigation to verify the relationship Z square equal to 4 pi square L square F square plus K square using a graphical method. So your plan should include an additional component required, the measurement to be taken, how the measurement will be used, and a sketch of the expected graph. An additional component, because we are using signal generator, is fine. Frequency can be found from signal generator, but Z, if you see Z, the relation of Z, so Z is equal to V by I. That means in order to find the value of Z, we need voltage and the current. That means we need voltmeter and then ampere meter as an additional instrument in this experiment. The measurement to be taken, so because we are going to take measurement of the frequency by varying different values of the frequency and then corresponding values of voltage and the current, so that we can figure out Z. So the measurements are voltage, current, and the frequency. How the measurements will be used. So now we have a voltage and we have a current. So we can use Z is equal to V by I to figure out value of Z, and then we can figure out Z square and then F square according to the equation. So that's how we measurement will be used. So I sketch expected graph, a sketch of the expected graph. Clearly, if you see the equation, this equation is in the form of y equal mx plus c. Clearly, Z square is your dependent variable, frequency, which is independent variable, K square is your Y-intercept, and this whole thing is your gradient. So that means you can expect that you can have a graph of F square and Z square on the y-axis, and clearly we have some y-intercept with the positive slope, so you can expect a graph with some positive y-intercept, and you can, if you wish, you can say that this should be the y-intercept and it should be equal to K square. A student investigate how the volume V of air in a syringe varies with the pressure P. She plots the graph of P against 1 upon V as shown. This is pressure in kilopascal, 1 upon V into 10 to the power 5 meter minus 3. Determine the gradient of the graph. So for the gradient of the graph, you see that this is 0, 0, and I can take this point as a second point, so we don't need to consider this. So we do rise over run, And for gradient, the rise over run. So gradient is, you can figure out y2 minus y1, and if you do that, you have a vertical axis which is 200, and okay, this is 210, so this is 210 minus 0, y2 minus y1, but don't forget this is the vertical axis, don't forget the value of kilo, so 10 to the power 3, and x2 minus x1, so this is 7 minus 0, so 7 minus 0, and of course you have 10 to the power 5 here as well, so 10 to the power 5. And if you solve this, your gradient would be equal to 30 into 10 to the power minus 2, or you can say that it is 0.3, and unit should be 0.3, and unit should be Pascal meter cube. So this is your gradient of that graph. The investigation is carried out at a temperature of 25 degrees centigrade. Calculate the number of molecules of air in the syringe. So number of molecules, if we need to find, we use equation PV equal NKT, and N is the number of molecules, so N is equal to PV divided by KT, where PV is the gradient of the previous question, K is the Boltzmann constant given in your formula sheet, and T is the temperature in Kelvin. So you must add 273 to convert this into Kelvin. If you do that and if you use all the values, so PV is the gradient that you found in your previous question, 0.3, K is the Boltzmann constant, which is 1.38 into 10 to the power minus 23, times temperature after converting into Kelvin, it is 298. So N would be equal to 7.3 into 10 to the power 19. These are the number of molecules. A student places two Polaroid filters together. He noticed that when he rotates one filter relative to the other, the intensity of transmitted light changes. He investigates this effect using the arrangement shown. State why the student should keep the distance between the filament lamp and the light meter constant. That means, why should we keep that distance constant? The reason is the student is investigating effect of rotation on the intensity, and of course intensity of the light also depends on the distance. Greater the distance, lower the intensity. So that means the distance between lamp and light meter should be constant, so it is not affected by the distance, it is only affected by the rotation of the polarizing filter. So that's why we can keep the distance constant, so that intensity does not affected by the distance, only affected by the rotation of the filter. State the main source of uncertainty in this investigation. Whenever any investigation or experiments involve measurement of lights or falling of light something, we should do this experiment in a dark as possible as we can. So the surrounding light or the background light can affect our investigation. So we can say that the main source of uncertainty is the light present in surrounding or in background. The relationship between the measured light intensity I and the angle theta between the filter is given by I equal to k cos of theta whole power n, where k and n are constants. Explain why a graph of log of I against log of cos theta should produce a straight line. Again, a typical question of your unit 6. You need to rewrite this equation, which is a kind of trigonometric equation in the form of log equation. So we apply log, and remember, here we will have to apply log of base 10, log, not log of base e, like meaning we don't have to use ln here. We will have to use log. So we apply log on both sides. So log of I equal log of k times cos of theta whole power n. So first we are going to apply first law of logarithm. These two, k and cos of theta whole power n, are being multiplied in a single log. According to first law, we can write these two as a sum. So log of k plus log of cos of theta whole power n, and then we need to apply the third law of logarithm. We need to bring this n down before the log here according to third law. So we can say that log of I is equal to log of k plus n log of cos of theta, because we need to plot graph of log of I against log of cos theta. So this is our dependent variable and log of cos theta is independent variable. So you need to rearrange this equation as y equal to mx plus c. So log of I is equal to n log of cos theta plus log of k. So you can say that y is equal to mx plus c. So where m is n, m is the gradient, which is n, and c, which is y-intercept, it is log of k. That's why we have a straight line. I did this derivation in quite detail for every step, but you can skip these two if you know how to solve logarithmic equation. The student records the following data: theta I in lux and cos theta. These are the values. Plot a graph of log of I against log of cos theta on the grid opposite. Use the additional column to record your process data. Determine the value of n and determine the value of the k. So first of all, you need to find log of I and log of cos of theta value, and you will have to use your calculator and log button to find the logs values of I and the cos theta. If you do that, you have log of I values and then log of cos theta. I use two significant figures here, three significant figures. If you wish, you can use two, so it's fine. And then we need to use these values to plot the graph to figure out value of n and then k. So this is how the values of log of cos theta and log of I are there, and we choose x-axis because we have a log of cos theta independent variable and its value is negative. So instead of choosing origin on the left hand side, we will have to choose origin on the right hand side, so that we can mention these negative values on the x-axis or negative x-axis. So that's how you can choose your graph and your values and your scale, and you can plot your corresponding plot here and then line of best fit. Remember, you must show the values on the x-axis with the unit. This is the best fit, line of best fit, and then for n we need to find the gradient, and you know we need to find n, and from that equation n is the gradient of that line, which is gradient here. So for gradient you need to choose 2 points on the line, and if you choose that, now suppose I'm choosing this point here, like that. So this point is no, it's not a good point. Let's just talk about that one. Yeah, this one is the better point. So the coordinate of this point will be minus 0.15, comma, and the vertical value would be 2.456, and then we can choose another point like this one is also good point. Let's see, because we need to choose as big as the triangle as big as we can. Let's just talk about this point here. The coordinate of this point will be minus 0.7, comma 1.65, 1.6, 1.67 approximately. So 1.67. Now we have a point, so we can figure out the gradient, and then gradient would be equal to y2 minus y1, so 2.46 minus 1.67 divided by x2 minus x1, so minus 0.15 minus, and then minus plus, because the minus of the formula and minus of 0.7, so 0.7. once you solve this, n is equal to 1.43 or 1.4. This is the gradient. And you can write the unit as lux. Second thing, we need to find the value of k, and you know that log of k is the y-intercept. So first you need to figure out the y-intercept. My graph, because I did not have a space, but if you need to find the y-intercept, so you need to extend in a backward direction your best fit line. So if you do that like this, because my line is going out, so I can expect, if you do in your notebook, it will be giving you some value of y-intercept somewhere after 2.6, and if I say that this is 2.6, 2.5, so I'm just, for your understanding, I'm taking some estimated value. It should be around 2.6566 or 67 or 68. I'm not sure. So your value of C is 2.6. Let's say I'm taking 7 or maybe 8 once you complete your graph. So this is your value of C. So log of K is equal to 2.67. If you remove this log or you take anti-log, so K would be equal to 10 to the power 2.67, and then K would be equal to 467.7. This is the value of K. Thank you very much and have a nice time.